Hi everyone, and welcome to our video where we will be making a graph based on information. But before we do that, let's take a look at some of the new rules that we'll have to mix with our original function along with derivatives. So here we say, so this is the first derivative test for intervals of increase and decrease. Suppose that f is continuous. If f prime of x is greater than 0, then f is increasing. So we have these two matching. And so what that means, let's start drawing a little sketch right here. So here's my axis. And what I've currently have is let's draw something that is increasing like that. For now, we'll just stop it there. Okay, so this is showing the f is increasing, but let's mark it. Any slope that I draw, any tangent line, would have a positive slope. Okay, so all of those in the blue is showing our derivative is greater than 0. So remember, that means it's a positive slope. So all of these in the blue would mean that that's a positive slope. Okay, then the next bullet says if f prime of x is less than 0, let me go ahead and underline that, then f is decreasing. Okay, so let's draw something that's decreasing. There we go. And then we can do this a similar thing. Let me mark it here in purple. So here it's decreasing because it's going downward from left to right. And then again, any point I choose on that downward, on that decreasing part, has a negative slope. So this is our f prime of x being less than 0. So this part, all of that, negative slope. Okay, then we've got if f prime of x equals 0, then f is a constant. Okay, so let's say we've got, so just to continue this graph, remember a constant is a horizontal line. So let me mark it in green. So here's our f prime of x equaling 0, f being constant. We know, so no matter where I draw a tangent line, it's still a horizontal line. This is where f prime of x equals 0. Okay, so that's where the graph is constant. Let me mark it. F of x is constant right there too. Okay, so we're breaking down this information and just seeing how it works in different ways. Let's also go to these other bullets. So it says, or if f prime of x equals 0, then f has a turning point. Okay, so keep in my green. So connecting where I had blue and purple, right at the tip, there's a turning point right there. Well, it has to go from a positive slope to a negative slope at some point. So that means there should be a slope of 0 there. So at that moment, the derivative is 0. Okay, so at turning points. Okay, and the other things that we have, the x values where f prime of x equals 0 are called critical values. Okay, so whatever that x value is would be called a critical value. The x values where f prime of x is undefined would also be called critical values. Okay, so those are special cases too, and we'll see that soon. Okay, so but this is all just getting ready to help us with future problems. But let's use some of this information now to just make our own graph. So it says draw a graph where f of x has a positive derivative over negative 610 and a negative derivative everywhere else. All right, so let's set up, and our answers can vary. Okay, so I'm just gonna say here's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so because that's the middle interval that they're talking about, and then they said negative everywhere else. Okay, so they want f of x to have a positive derivative over negative 6 to 10. Okay, so for it to have a positive derivative, let's star that right now where I had the blue before. That's where I just need to make sure the graph goes up from left to right. Okay, so let's do something like, I'm just gonna have it here, and then here's something that goes up from left to right, like that. Okay, and then I might need to make a little bit of a change on some of this. Maybe I need to rewrite some of that curve. We can fix those little things, but I just wanted to take care of this part. Done. And then it did say negative derivative everywhere else. Okay, so a negative derivative everywhere else. Well, It doesn't say it has to be continuous or anything. So this blue is looking fine. Now you can have different answers. I'm going to just put a big solid dot here and a big solid dot here. And then now I'm going to draw the rest of it. So a negative derivative everywhere else. I'm just going to do an open dot and then have it go downward. That's how that would have a negative derivative. Okay, so as long as the graph is going downward, as long as this is our f of x is going downward, then that would give us the negative derivative. Again, downward from left to right. Okay, so this other part from the left of -6, again, I just have to make sure it's going downward. So I'm going to put my open dot here, left to right, draw something downward to get to it. And I'm just going to have an arrow, put there. There we go. Okay, that's it. Okay, so our answers again can vary. As long as it makes these true, it's gonna be good. So you can look different, but that's it for now. Okay, so we'll come back to these rules and these throughout this whole section, just making sure we can see what's going on with our graphs here though. Okay, so thanks for watching. If you have any questions, please let me know.